Hello there, this is a full screen recording. This video is going to go over the answers for the reading quadrangles exercise. Again, please do not take photographs of the answers and do not video this presentation and put it on some website. And I'm going to do my best to try to draw on this thing, but I'm learning with my tools. So number 1A, what is the name of the quadrangle? Well, it's given to you right here, the Cedar Mountain Quadrangle. 1B, what is the only latitudinal boundary number shown? It's this number here, 37 degrees, 37 minutes, and 30 seconds, because that refers to this line. The longitude is 121.30, which is the number here. And then what is the contour interval? So to figure that out, you probably have to zoom in. I'm going to try to zoom in a little bit. So here's the 800 line here, and this is 1,000 here. So that's 800, and there's 1,000, and there's 5 contour lines between them. So that must mean that the contour interval is 40 feet. Okay. So moving on, we're going to look at this picture and answer some questions about where you would find latitude and longitude. So 2A, where is the lower latitude line's number designation? It's here in B prime. Okay, so I'm going to get rid of that oval. Where would you find the upper latitude? Is in A prime, which is here. So again, get rid of the oval. Where do you find the rightmost longitude? Is D prime, which is this line here. So let me get rid of this stuff. And then, of course, the next question is going to ask you, where do you find the leftmost longitude, which is C prime, which is letter C. What information can you find at letter E? You do find the contour interval, and you do find the fractional bar scale and the ratio scale and the bar scale. So the answer is all of the above. Okay, number 3, A. What is the contour interval of this map? Again, I have to zoom in to look at it a little bit more carefully. So there's 6,200. I see a contour line here, and then 6,800. So I'm assuming this line here is 6,400. That means that the contour interval is going to be 40 feet. Okay, because the darker lines are index contours, and there's 5 contour lines in between each index contour. What is the elevation of the top of the hill at letter A? So let me zoom in. So that's 6,800, and the contour interval is 40 feet. So you go up by 40. 6,840, 6,880, 6,920. This is 6,960 at the contour line. And then if you want to do one more, a half of a contour interval at 6,970, that would truly be the elevation at the top of the hill. Okay, so I would accept 6,960 or 6,970 for 3B. 3C, if you examine the box in B, which direction is the river flowing? Let's zoom in again. If you notice very carefully, like for example, this contour line is crossing the stream and the V is pointed that way. That means the water is flowing in that direction. So that direction, if we zoom out, is west. So the stream is flowing west. So that's 3C. 3D, if you look at the box in the top left, which one is going to have the non-steepest part of the contour like lines? So, or the least steep. Well, this is a pretty steep slope because it has many contour lines on it, or the contour lines are very close together if you notice, and so is letter E. Letter C is the only place where the contour lines are not that spaced close together. So the answer is technically letter C, is where you find the slope is the gentlest. And then finally, 3E, find Mount Broderick. And what is the elevation at the top of Mount Broderick? Well, if you notice that the number at the top there is 6,706, and that's the elevation at Mount Broderick. Okay, so I'm making a mess of things here. We're going to do some math now with question number 4. So you have to convert the fractional or ratio scale to the verbal scale. So the way you do that is that you take that big, now this, it means that 1 inch is 50,000 inches. So you take 50,000 inches, and it's probably not going to let me write that out. So let me undo. This thing is finicky. 50,000 divided by how many inches in a foot? So that's 12. So you take your calculator, which I have a calculator here in my hand. 50,000 divided by 12 equals 4,166 feet. Then you take that number and divide by how many feet in a mile. So it's 5,280. And the answer is 0.78. 0.78 is the answer. Miles. Okay. You do the same thing for the bottom example. This is 1 inch is 100,000 inches. So you take 100,000 divided by 12 equals some answer, and then divided by 5280, and that equals 1.57. Okay, so moving on, this is a gradient problem. So it asks you to determine the gradient between the 2 points given. So the higher number is going to be your E1, and then your lower number is going to be your E2. So it's 580 minus 560, because it's E1 minus E2, and that equals 20. Okay, 20. It's not going to let me do it. 20. Okay. And then it says the distance between them is 2 miles. So you want the bottom number to be miles anyway, so divided by 2. And that equals 20 divided by 2 is 10. So it's 10 feet per mile. Okay. Next is question letter B here. I think it's number 5, 5B. So what's the distance between the 2 points that are shown here? Well, it says that, the first thing you have to determine is how many miles is in this map scale. So you do your math trick. 24,000 divided by 12 equals divided by 5280 equals 0.37. So 1 inch equals 0.37 miles. Okay, horrible. 37 miles. So now that I know that 1 inch is 0.37 miles, it tells me that the distance between the 2 points is 4.5 inches. So 0.37 times 4.5 equals 1.66 miles. Okay, letter C. Find the 2 latitude and longitudes indicated. So that's the latitude indicated. The longitude is going to be here at 50. So where those 2 points connect, it's going to form a plus, and your plus is going to be right there. And I knew it would make an oval. What I've done is that I've blown up that for you here on this picture. So it wants to know the elevation of the contour line directly below the plus. Well, if you study the map very carefully and you kind of, you can blow it up, when you come up here and look at it very carefully, you will determine that the contour elevation of that index contour below this plus is at 1,000 feet. So that's 1,000. Okay. Question number 6, what's the contour interval of the map? You have to look at it. So there's 6,800 and there's 7,000. 7,000 minus 6,800. Minus 6,800 is 200 divided by 5, and that's 40. Okay, so the contour interval is 40 feet. Then it asks you, what is a relief from point A to point B? So you have to, again, blow it up and look at it. Point B is actually on an index contour. So 7,000, 7,200, 7,400 is B, and it looks like 6,200 is A. So 7,400 minus 6,200, 7,400 minus 6,200 is 1,200 feet. So that's the relief between A and B. That's the difference in elevation between A and B. Letter C asks you, why is this road not straight? Well, the reason is because it's a very steep slope, and you have to switchback it, as it's called. in order to get down safely. You can't just drive down or you'll be going down like a missile. This question asks you, is this stream braided or meandering? And it is a braided stream because you see many, many channels as opposed to a single stream where you have like a snake-like appearance. This is the final question I'm going to do because this last stream gradient problem is a little bit tricky and I think I wrote it wrong. So finally, question letter E, which direction is the Squall Creek flowing? Well, we're assuming the top of the map is north. You see that the contra V's are pointed south. That's uphill. That means that the river is flowing north. Okay. So with that, this completes this presentation. You can go back and rewatch it if you want to, if I went too fast. And again, do not copy or put any of this information on the internet. Thank you.